It's 8:59. I got about 4.5 hours worth of material here that I'm going to download in about 15 seconds to you guys. So we might as well get rocking and rolling. Welcome, everybody. I don't know whose brilliant idea it was to have Saturday morning after Friday night. It was like poor planning, but here we are at 9 o'clock in the morning. So water, the number one plant nutrient. You guys, ready for this? A heresy. There is no such thing as a soil deficiency in anything. Nowhere, anywhere. Plants live everywhere on this planet except, well, even in ice. They even lived in ice. They do. So they live everywhere on this planet. There is a plant adapted to your site. No mineral nutrients necessary for those plants to survive. However, on planet Earth, the one thing that we know that plants won't live with is without water. So we need water. Anybody who's from California here? Isn't it amazing? They design everything. All these buildings, all the roads, all the subdivisions, everything is designed to catch that water and make it go away fast. And then they bitch that they don't have any water. Doesn't make sense. So we're going to talk a little bit about keyline design. I first heard about it through permaculture texts. This is, if anybody's ever seen this, that's the first edition hardcover copy of Permaculture Designer's Manual. It's so old that in the back, everybody who would ever take a permaculture design course, their names and addresses were in the back. So try that today, and it's like probably volumes and volumes. I didn't even have this when I got started. Two little things that were barely thicker than a magazine, Permaculture 1 and Permaculture 2. Was kind of where I heard about it, and it kind of like really blew my mind. It's like, well, just with the cultivation pattern of what you're doing, is that out of focus? And you know how to do that? With our cultivation pattern, one of the goals, one of the aims, if you're speaking Australian, is to get the water from valleys high up in the watershed out to the ridges. And it laid out all these different diagrams. And wow, it was pretty cool, fascinating. The idea is to keep all the water on the landscape so you can actually use it for productivity. And you'd have a landscape that would be designed somewhat like this. Instead of all the water, think about this. You pour water on this landscape. If the 1 inch of rain falls on that 40 acres right there, the 1 inch that fell on the ridge is all down in the valley. Down in the valley, there's like 40 inches of rain now because it's collected off all these ridges and sinks down in the valley. So you have wet spots that were created by the shape of the land, and you have dry spots that are created by the shape of the land. It's actually the water interfacing with the land that actually shaped it that way in the first place. So one of the goals would be to have these interconnected channels. And so in the Permaculture Designer's Manual, Permaculture 1, Permaculture 2, I heard about this book right here. What a trip. Ooh, almost just spilled my coffee. Has anybody ever read this book? How many people in this room? We got, 50 people in this room. Okay, so about maybe 20% have read this. Out of the 20% that have read this, how many of you guys have made it past page 126? We got 1, 2, 3, 4, 5 people have made it, 6, 7 people past page 126. All right, of you people who've made it past page 126, how many of you have been practicing this for the past 20 years? We got one. Okay, so now the thing is, I'm willing to bet a nickel that your systems and my systems look different. It's fascinating. Why is it that 1 out of 50 people at a permaculture conference has done it for 20 years, and our systems look different? If this book was the rules, it should look the same, kind of. That's where we're going to get into this. What? Because it lies. Oh, this. What really caught my attention is I grew up organic biodynamic kid. My dad was a composter back when if you said compost, you could get arrested for being a socialist. And so I read this thing about one of the primary objectives here is to develop deep, biologically fertile soil. We're going to make topsoil. It's like, you can't. Man, I read all the books. It takes zillions of years to make topsoil. You can't convert subsoil into topsoil. You can't do it. You have to make compost piles and turn them 1,000 times and add it on top. You create soil by adding it on top, right? But I thought that was pretty intriguing. Maybe we actually can create fertile topsoil. The idea is all these cultivation, irrigation, stock management techniques is to convert subsoil into topsoil. Of course, they go, say, 10 to 15 tons per hectare per year, 6 to 8 inches a year. But that right there, how do we convert the topsoil, the subsoil into topsoil? What a brilliant idea. One of the things we've got to do is we get plants to grow, especially the powerhouse of soil building is grasses. And so many different times you hear in permaculture circles, well, grasses will kill your trees. They're bad for it, whatever. You add mulch, and that builds the soil. Well, not really. The mulch kind of creates a hyperactive decomposition zone. And if you try this experiment, make a mulch circle and keep it mulched. Do it on a lawn because we want like bombs, not lawns, or whatever that phrase is. So you put the mulch on the lawn and then keep adding the mulch and watch what will happen is all of a sudden that mulch circle will sink because what you've done is you've short-circuited nature's soil building things, which are the roots of grasses. You want those grasses to grow, green solar panels, they pump the roots down into the ground, they actually inflate the soil. And if you mulch that, it'll collapse. Hyperactive decomposition zone, all those nutrients are released, your plants grow better, but you're not building soil. You're actually killing the soil. So I figured, what the heck, let's try it out. Let's try it out on this farm here. And I've even read research that actually somebody over and over, a bunch of keyliners are saying that keyline design, keyline water management actually builds soil. So somebody from our university did some research, and they went out and they studied NPK on a number of different keyline farms, and they found no significant difference. That's not what we're talking about necessarily. We're not necessarily talking about an NPK soil test. What we're doing is we're converting subsoil into topsoil. This is a picture of our farm taken 2 years ago, actually. And what I thought was fascinating about this is this shows evidence that we actually have converted subsoil into topsoil. You notice how it's kind of reddish across the field? We moved on to a red clay farm 20 years ago, and we've actively farmed this stuff right here for 20 years, and look how it's not red anymore, but you look at the ruts in the farm track and it's red. How have we changed the red into darker? And then check this one out. This last summer, we had a guy from USDA come out and dig some test pits. That's what our soil looked like. 20 years later, it looks like this. We turned clay, pottery clay, brick-making clay, get an open-source brick-making machine. We would have been in business. We'd have made 30 or 40 bricks by now. It's still a heavy clay soil. You know, you look at that. It's like frosting on a cake. You know, schmeary, really schmeary. But it's black. Well, not quite black. Blacker, yeah. No magic silver bullets here. So that's the picture of the farm 15 years later. You've all seen that. Wrote a book. Buy it. Good. How many have read this book, by the way? You guys are weird. You guys are weird. What's really interesting, I'll confess to you because this is a small room, and if I cover up the microphone, it will not be recorded. I wrote this out of frustration. It's like, for crying out loud, I'm sick and tired of explaining myself to people. So let's just throw it out there. In there, I actually dealt with, you guys have read it, I've dealt with keyline design a little bit. But this guy wrote a whole book on it that gets confusinger and confusinger. I wrote one chapter, and the further I got in that chapter, it's like, I'm going to have to punt. It's too much for one little chapter. I can't pull it off. Where this whole book got its start, Yeomans, of course, was a student of soil and farming and agriculture. Right about the same time, it was actually a little bit before Yeomans got started, actively farming. This whole thing got started in the US of A, contour farming. And the idea is to have all of your fields perfectly on contour, the field edges on the lower slopes. And what that would do is that would reduce erosion, reduce sediment going into streams, lakes, rivers, and ponds, and all that kind of stuff. And so you'd end up with something that would look kind of like this. Excuse me. And what Yeomans realized when he started looking at this, he says, this is insane. This is insane. I've got a rectangular combine, for example. How do I take a rectangular combine around a circular field like this? You go straight, and you go, it's not efficient at all. These little triangles, good luck with a 40-foot wide combine turning around in a silly little triangle. It's an amazingly inefficient system, and it's really actually not all that effective. It slows the water down, yes. It takes longer for the water to get down on the bottom, but it still does the same thing. It goes down to the bottom into the valley, and it goes away. So in the bottom down here, you put in a Hinkenbottom drain to make the water go safely away. All right, vocabulary. I'm going to be talking about a bunch of stuff. I'll probably say it so fast I won't even realize that I'm saying strange vocabulary to you guys. So hold up your left hand. It's the easiest here. Look at in a fist, please. Thank you. You can hold it this way. It's the same thing, but we're just going to do vocabulary. This guy's a wise guy. Your what's that? Your index finger knuckle down to your pinky finger knuckle. The line between those 2 points, that's the main ridge of a landscape, or in this case, a handscape. So on this main ridge, we have hills and saddles and hills and saddles and hills and saddles and hills. Everybody follow that? So we've got main ridge, we've got hills and saddles. Well, coming off the hills are primary ridges. It's the first ridge that comes down off that hill. Coming off the saddle is a primary valley. So we got main ridge, hills and saddles, primary ridges, and primary valleys. I'll be speaking mostly about primary ridges and valleys. If we take two of these main ridge systems and put them together, what do you think's running down the middle of two main ridges? How about a main valley? Notice how your knuckles come together. They're like the sinuous. That's what the streams do. We're made out of water, so we behave according to all the rules of water. So main ridge, hills and saddles, primary ridge, primary valley. Where the primary valleys, all of a sudden, you got these fingers going along here, it's no longer primary valley. It just turns into this little web between your fingers. That right there, and we'll talk about this later on, is the key point in your handscape, in that primary valley. This is the key point in the second primary valley, and this is the key point in the third primary valley. And if you look at where these key points are, where my fingers come together, they're related to one another by elevation. Some people have different shaped hands. My middle knuckle is bigger than my index finger knuckle because I bashed it on the shower at Kevin Munoz's place. But some people, they have, it's a straight line going down this way. We have all these different hand shapes in the room, but we all have these key points located in relative relationship to one another. If you're looking at a cross section of the slope, it'll be like this point right here. One of the reasons why I put this in, I talked about this in my book. If you're going to do some kind of earthworks, dirt moving, there's like 3 places where you can move the least amount of dirt and have the biggest effect down slope, and it would be out the shoulder, at the elbow, and the wrist. Now, I don't know how to do shoulders coming together, but that's where the key points are oftentimes located there. It's no longer valley, it starts to be head wall of the ridge. If you're looking at a contour maps, on a simple contour map, you'll notice that the contours lines are wider apart, then all of a sudden where they go skinny, that's where it starts to climb the head wall. That's your key point right there. And what I find fascinating is in this book right here, yea, verily, I say unto you, Yeomans, chapter 3, verse 12, only primary valleys have a key point. That's it. The only primary valleys have a key point. And I find it fascinating, somebody teaching keyline design goes down here and puts a thing here. This is not a key point. The key point would be there, 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 and there, up in the primary valleys. But that's what it is. All right. Where do you think a key point would be in this picture? This is very important to be able to identify key points. Should be pretty obvious. This is a simple, easy to understand one. Right about there. You got that? Just when you're looking around, when you're driving down the road 70 miles an hour, you're going to be looking at key points all the time. I do. Yeah, right. What's interesting about at the key point, what happens when rain falls on this, let's say it's a nice gentle rain, the soil will only absorb so much water so fast. And if there's just a slightly more rain than the soil is able to absorb, it doesn't like form a stream yet. It's like a sheet, like this big amorphous amoeba kind of like slipping down the slope. And anytime you walk on the ground, you hear the squish, squish, squish. There is a sheet of water slowly moving down slope. When a raindrop hits the soil, it pounds the soil. The finest particles go into suspension in that drop of water. And as that sheet of water moves down slope, those fine particles go with it. And when they hit this little flat spot right there, the water sinks in, the finest particles get filtered out. And what are the finest particles if you guys are doing soils? The finest particles in soils are called clay. Little teeny tiny fine little particles. So what you'll end up with is a little lump, a little mound down there, and you see it's a little bit greener. It holds more moisture. That's where the moisture of the water is accumulating. You'll have at most key, well, not most key points, every key point I've ever found. At every key point I've ever found, there's enough clay there to make a water retention structure of a certain size. And I'm being careful with my language for a reason. I'll get to it later. Anybody see where the key point is and or might be here? If you are of rather strange thinking, would like an entertaining video, go to YouTube, look up Darren Doherty Goes to the Beach, and he starts looking at human shapes and forms. And isn't it fascinating where you see like these lines come together here? There's a wet spot and a little mound right there, and he goes into full detail. Right there. There is an accumulation of the clays locate there. There's more water accumulating there. But however, if we read, Yeomans chapter 5, verse 12, whatever it is, I don't know what chapter it is, or verse. This landscape is kind of simple. It's obvious where the water is accumulating, but you know what? That's kind of like a key point up there too, isn't it? It's kind of like the valley walls come together, and there's one there. Then if you want to get like Zen sand meditation garden kind of thing, this is a fractal universe. Everything gets smaller and smaller and smaller. Every time you see these two coming together, that's a micro key point. There's a micro key point, smaller and smaller and smaller. So which one's useful? Which one do you want to use? My point here is that it may sound simple here, and it is simple. It's not complicated. It's complex, not complicated. But then you come out to certain landscapes. What the heck? Right, where's the key point here? Hello? How about any one of those places? Yeah, they kind of all fit the criteria. So this thing that there's only one key point, and there's only one key point, and only in the primary valleys, yeah, kind of, maybe, I don't know. When we find our key point, we got this primary valley, where our fingers come together. When you find your key point, a contour line from that key point going out towards the ridge is the key line. And then as it goes out towards the ridge in a certain shape, all of a sudden it'll turn the corner. That's where the key line stops. Key line starts at the key point and goes out the primary valley until the shape of the valley changes. And it's really, this is important to a certain extent simply because really, if you're going to go design a water management system on your property, these are the easiest places to start. You know, most of the time you go somewhere near the key point and you lay out your lines and however you want to deal with the water on your farm, that's usually the easiest place to do it. It really helps. So I really, I drive 60 miles an hour, I see key points and key lines, and that's where I'll go start. So if I'm going to come to your farm and help lay out a water management system, I'll be like looking this, boom, right over there. Then we go over there, then we dial it in closer and closer using more tools. Now in the simplest form, we have our key point and our key line. You got that? Primary valley has a key point. Key line is that contour line from the key point. Anybody confused about that yet? Good. Everybody's asleep. In the simplest form, the key line pattern cultivation kind of works this way. At the key point and the key line, if you're just going to be growing whatever your crops are, whether you're using a wheelbarrow and rototiller, double dug, whatever those things are, or a 1,000,000-foot wide combine, from the key line, you cultivate parallel to the key line down in the valleys. Then what you do is on a ridge, you start out at the bottommost contour line on the ridge and cultivate parallel up. What ends up happening when you do that, just because of the shape of the land, and it's a real trip when it works this way, is that all of a sudden you'll have, as you move down these valleys, your cultivation pattern will kind of shift this way, so the water will naturally want to drift towards the ridge. And the same thing on the ridges, the water will start to drift from high up here, in this little key point right here. It'll start to drift out towards the shoulders and then sheet across the ridge. And that, in the simplest form, this right here is the summary of the whole key line system. Key point, key line, from the key point, parallel down, lowest reference contour, parallel up. And that's it. You guys can leave. Got it. Cool. However, you saw this picture here, right? We don't live on the oldest continent on the planet. Our continent is a lot younger. Landscapes are a lot more convoluted here. They're not so smooth and regular featured. Twice in 20 years of doing this, twice have I gone to a property, helped lay it out, where this actually worked according to how it was supposed to work. Only twice in 20 years. So what the heck am I supposed to do? Even on my own farm, because this right here, this is where I got started 20 years ago. Where the heck do you start? I'll tell you where I started. I started right there. And you lay these lines out, and it didn't really work. So then I started there, laid the lines out, and it didn't work, but it brought me around this ridge over here. And I said, hey, this is kind of close. Why don't I start here? And I started measuring. And so what I'm going to show you later on is what I kind of figured out by frogging around and trying to make it work on the ground. And it was fascinating. Some things that are going to influence our water management design is the slope. How steep is your ground? Like that really, really steep one? Or flat? The soil type, sandy soil, clay soil. That determines its permeability. If you're on a super granular, thick, coarse sand, like crushed pumice out in Hawaii or something like that. Water's going to infiltrate really quick. That's going to affect your decision making about this. Your intended use: are you going to grow row crops, produce? Are you going to graze animals, grow grass? What do you plan to do? The kind of equipment that you have. That like I said, what is that? The double dug kind of fork thing, or a broad fork? Is that what it is? Good. Don't get me going. Then the depth and type and structure of bedrock. There are places, and I know California makes the news quite often, well, when it rains here, that all of a sudden you'll see this massive mudslide, that all of a sudden the water kind of soaked in and the whole hillside goes away. There are places where if you have like a underlaying rock that's shaped just so, let's take, do I have a drawing board? I don't have a drawing board. Oh, is that one in the corner? Nope. If you're going to have extra water soaking in, and it's certain kinds of soil, like most specifically are what called dispersive clays. You get that clay wet, it's like yogurt that you shake and you go, it'll pour right out of the bucket. So you want to be aware of your depth, type, structure, bedrock, and all these other factors. We don't have enough time to get into that. So we're going to look at this right here. Who sees where the key point is? Ding, ding, ding. Got that? All right. Follow the bouncing arrow. Now, what are we going to do from the key point? The key line is what? It's a contour line from the key point. And because of the shape of this, I can't make a curvy line on PowerPoint. I'm not that good, not this way. So there's this, whoop, where'd it go? There it is. There's a key line. It's actually bent in the shape of the valley, but we can't see it because of the three-dimensional thing. So in the valleys, we're going to work the land, whether we're cutting hay, plowing the ground, whatever it is, we're going to work the land parallel down from the key point in the valleys. Okay, got it? Then what we're going to do is we're going to start out here and find the lowest ridge and start going parallel up. This is a simple, by-the-book keyline layout. There it is. From the key point, parallel down, lowest reference contour on the ridges, parallel up. The water will naturally start to migrate towards the ridge in many cases. What if we take this picture here? Who sees where the key points are? I've borrowed this slide from a person's presentation who does keyline presentations, simply because I borrowed this slide from them. Because when we read the book, we find out there's only the primary valleys have a key point. There's a key point, there's a key point, there's a key point. These key points up there, key point, key point, key point. We start at the key point, make our key line, go parallel down in the valleys, start at the lowest ridge, go parallel up. That right there, according to the Yeoman's book, is not a key point. This is in a secondary valley. So we have primary valleys, secondary valley, main valley. That is actually a really good place. That's a really good place to start designing a system, depending on how your property line lays out. Let's go back to this right here. This is by the book, follows all the rules, keyline design, simple. Well, what's so wrong about starting a system there? Nothing. It's just not a key point, and that's not where a key point is. These are the key points, here, 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 here. So does that make somebody building a system like this wrong? No, it's different. It's just different. We're all interpreting this. All right, who's Australian in here? Anybody? We got to have one. You. All right, Colin. You guys were kicked out of every respectable country on the planet. All right. I'm convinced that although this guy was able to speak English-type words, it's not easy to read. And also think about it. Try to describe this using words. It's challenging. You're trying to describe the shape of land. Go ahead, describe a donut to me using words. So there's nothing wrong with this. This is just a different interpretation of using the same principles. And that's my point, is that using the keyline design framework, we are able to manage the water on our property so it spreads it from the valleys, high up in the valleys, to the ridges. And where you locate, where you start your system, doesn't matter. Oop. It does according to the certification that I've never taken concerning keyline design. What if you don't own that spot, or you don't own this spot? What if you own this piece right over here, the property lines over here? There's a power line over there. There's a house over here. There's a driveway over here. We have to be able to adapt these to our conditions to make it work. And one of the goals is to keep all the water on our site, If you live in a place that's too wet and it's always too wet in the bottom of a swamp, you're living in the wrong place. You should build a boat. That's fine. So this is according to, Yeomans, chapter 5, verse 12. You're going, in the valleys, you can't even fit a tractor. Think about that. We can't even fit, and actually it's page 45. Page 45, right in here. Oh, I got to find it. It's classic. He basically says, it's not 45, it's 43. Anyways, he says, in places that have narrower primary valleys, this doesn't work. It's right in here. He says, this doesn't work. So what I got stuck with in Wisconsin is something not in the book, because it doesn't work on my place, but it didn't stop me. So this would be according to Keyline plan. You go in the valleys, parallel down, reference on the ridge, parallel up. How do you deal with secondary valleys? Never talks about it. Never talks about how to deal with secondary valleys. Well, let's make it spread from there to there. This is done according to the book. Is this different than the one I showed you earlier? Yeah, it is, isn't it? It's, first of all, the whole system is designed around a thing that's not really a key point. But the water still migrates towards the ridge. Now, what if you have a tractor? Or let's say we're now farming with horses. No, let's farm with mules. Okay, a donkey. So we're plowing along, or we're cultivating cucumbers, going around. Whoop, now turn a corner. Whoop, now we turn a corner. Whoop, 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 whoop. That's a pain in the donkey. It's a real pain in the donkey because equipment doesn't turn like that. It's a real nuisance. This is just as problematic cultivating that way as the contour farms are. So is this right? Yeah, that's right, according to the book. And it just wouldn't work for me because my farm is shaped a lot like that. I've been given a lot of heat lately for using the term sweet spot. Keyline design, there's no such thing as a sweet spot. Well, chapter 5, verse 12, right over here. The principal consideration is that the final result should be 2 or more interconnected water storages in which the overflow from the highest dams caught by the collecting channels and directed to the next one. This is right out of the book. He said, this is a sweet spot. What you want to do is you want to find somewhere on your landscape, there is on every single landscape, even if you own that funny little piece down there, there is on every single landscape a line that is the single line that you can put on that property that will allow you to manage the most water on that property with the least amount of material moved. There is. Every single property has that. He even says so right here. Simplest, of course, is to connect this key point to this key point to this key point, and so on down the valley. And this is a classic right out of the Permaculture Designer's Manual. Exactly that. You watch this water, tries to come down, and it goes, dam to dam to doop to doop to doop to doop to doop to doop. Eventually makes it to the bottom and it goes away, or you put the pump on it and you pump it back up the top of the hill. That's in the Permaculture Designer's Manual. So let's go back to that same picture, this one here, right? Now let's design it according to the book. This way. This is exactly what he talked about, is building a high water collection, goes to the next one, to the next one, to the next one, to the next one. Then we'll let it sheet perfectly horizontal. It sheets down here, goes to the next one, the next one, the next one, makes a sheet, goes down. Is this right or wrong? It's just different. It's just different. It's right out of the book, but it's different. Now let's do the keyline cultivation pattern, and we all of a sudden say, hey, wait a minute, it doesn't really fit well, because now not only is it a pain in the donkey, I'm running into these water collecting channels. Water collecting channel, what a fascinating word. A water collecting channel, what do you think that might be? It's like a little divot in the ground that kind of goes linear in that direction, right? What would Jeff Lawton call that? A swale. S-W-I-L-E, a swale. That's a swale, mate. Right. So when it comes to keyline properties, does the decision whether you use swiles or not have anything to do with your ego? In your case, maybe. Okay, great, cool. Pushing the clutch on that one, my friend. You'll be all right. It has to do with what are your goals? What is your holistic goal? What are you trying to accomplish here? You can design your system, back. Oh, don't go too far back. You can design it this way. You can design it that way. These are your choices that you make based on what you're trying to accomplish. And you may choose to do it this way. You may choose to do it the other way. Well, now your donkey's really pissed at you because you're running into swiles all over the place. But what this allows you to do is some really cool stuff. This is a property that it was a half a mile from this corner. This valley going right down the middle of the water used to hit that low point and it would go away half a mile. So what we did is there's a pond here. The outlet to the pond is off the slide here. It goes out and around through this Keyline irrigation drain or water collection channel or swale. Goes all the way out here, hits a pond, fills up, and comes back here, and comes out 15 feet below this particular pond here. What used to go a half a mile and it's off the property, now went a half a mile that way and a half a mile back, and it only moved 15 feet down that valley. That's keeping your water on the site. Well, then from that 15 feet, it fills another pond that we can't see because this dam's in the way. Then it goes out this way to the next pond. You can see the new dirt on the dam down there. So it goes 1, 2, 3, a mile and a half, stays on the property, then hits this pond over here, and we weren't able to bring it back. We really wanted to bring it back because the shape of the land was different, so it now goes away. It spends like 3 miles on this farm. And I don't know, we can't see it in this picture. We'll see some of the pictures of this place later on. Before the system was put in, one of the primary plants growing on the ground here was prickly pear cactus. All right, now, okay, so now I'm in southwest Wisconsin. I'm totally confused. I've read the book over and over again, and I got like 3 different interpretations already. And then think about this, 20 years ago, I had to write letters and make phone calls to find a copy of this book. And back then, when you made a phone call, it cost $1.50 to get outside of the county. So it took a lot to find a copy of this book. And then you don't just get it. You know, you wait for 6 months, they finally ship it to you, open up, you read it, and then you go to a workshop and somebody steals it. I've had at least 3 of these stolen. So if you want to steal it, go right ahead. So now, you can get it at Acres USA. They carry that. It's also available online, free for download for those of you guys who do that. So now I'm in southwest Wisconsin. 3 different interpretations. I have no idea what's going on. He's trying to speak me in Australian. I don't understand Australian. And I run into this thing called USDA Code 600. We have like regulatory authorities that tell us what we're supposed to do and how we're supposed to do it. And so then what it says, terraces. Terraces are used for all these different purposes. This is where they're practical, et cetera, et cetera. It's an earth embankment or a combination ridge and channel. Ooh, wait, didn't we hear that? Like a keyline irrigation channel. We heard that before, didn't we? What, in my definition, what do I call that? It's a swale. The USDA is talking about swiles. Technically, theoretically, on your farm, if you're zoned agricultural, these rules apply. You have to follow these rules. You keep your farm, your fields on contour, and you may use terraces, which are a combination channel and ridge. So the USDA is telling us to be swilers. If you're going to do that, though, you'll want to dial it in and be accurate. We need to use tools to measure this. Winging it is good if you've been doing it for 20 years. I can get really close just walking a property because think about it. We've got at least 4 bubbles in our head, these little aqueducts where your cerebrospinal fluid's made, and they're all oriented different to one another. So we have the ability to tell altitude and side to side and front to back really, really accurately. You guys have bubble levels in your head. When you use them, you practice using them over and over again, you'll get better at it. My favorite tool is a laser level. It's accurate within an inch over 1,000 feet. So 1,000 feet in either direction, you got 1 inch accuracy for 2,000 feet over almost half a mile. I'm going to ask a question here. I want you guys to look very closely at these orange flags. Are those orange flags in this line, following behind me and the guy with the stick, are those going uphill, downhill, or perfectly on contour? I'm only taking 3 answers. Okay? You got it. These flags are actually going downhill at a 1% slope. Looks to me like they're going up, doesn't it? What happens is we've got eyes. We see this ridge line with the trees. We see that ridge line. We see where the hay was mowed. You'll have fences. You'll have roads. Our eyes, they're loose in your head and they bounce around all the time, right? So we're walking on the ground and these bouncy eyeballs are doing whatever. It makes everything look stable except for on Friday nights. And so we have these beautiful, useful tools, but they're not accurate enough to do this in most cases unless you practice. And just to prove that for a second, I'll just put that up there, and if you need to throw up, go ahead and leave the room. So back to the terraces. In cases where you want to keep the water on the property, a swale, a terrace, a keyline irrigation drain, whatever you want to call it, is a very useful tool. Now, what you don't want to do is get swale happy and start putting Sepp Holzer swales all over the place, because that boy knows how to make big ones. You want to have a context. Why am I doing this? Do I need to do this? Am I on flat, coarse sand or gravel? I may not need it. The water just goes right in. Is there any evidence ever that the ground goes squish, 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 squish? Well, that you might want to do that. If you have ground that freezes at all and stays frozen through the winter, I would go ahead and put it in, because when you have rain on frozen ground, it's going to go away. So let's have some kind of structure to hold it in place. Let's put in a swale. Hugelkultur, great idea. Let's go call a couple of contractors and have them bring in a whole bunch of brush from 70 miles away, put it in a pile and cover it with dirt. That's out of context. If, however, you have a bunch of brush laying around, it's in the site where you're working on, now you have a context where it's an appropriate technology. Put them across the slope at whatever, I didn't cover that, did I? Back here. One of the things about your contour farming that's significant, if you're going to do your contour farming, you have to have your fields within 4% of perfectly level, or else it doesn't comply, and they can slap you on the wrist and make it comply. Think about 4% slope. It's a 4-foot drop over 100 feet. In kayaking, that would be called Class 1 rapids. We don't want to create systems that cause erosion going to the ridges. It's already causing erosion in valleys. Let's not cause more erosion. So that's why I dial in with the laser level, because I try to keep it within 1% either way. So I use 1% slope as my steepest grade when putting in swiles. You can use hand tools, shovels and picks, and just observe this for a second. Just start looking around. In the animal kingdom, of which we are technically theoretically animals, it's usually the females that do the most work. And the guys kind of stand around, have beautiful hair and manes and colorful feathers. We are the more ornate, useless creatures. We have one purpose, and we would really wish you would use us for that more often. But look at that. The gals are doing all the work, and the guys are like important. He's important. Oh, supervising. The senior guy, oh yeah, over there to the left. Everywhere. You can use horses and plows. This is a friend of mine, Eli. He doesn't have his pictures taken because he wears blue clothing and shaves his mustache and has a big long beard. You can use a one-bottom plow. This is that one where I showed the orange flags that appeared to go uphill. See that line right there? Is that going uphill, downhill? We're perfectly on contour. It looks like it's going uphill, doesn't it? It's going downhill at a 1% slope. And when you put these systems in the ground like that and you watch the water go, you will watch water and it looks like it goes uphill. One of the places I work at is a monastery, and the farm manager of the monastery, like a year afterwards, I go down for another tour. He goes, oh yeah, and here's the place where Mark Shepard made water go uphill. And it looks like it. It really does. So you can use, somebody called me treeses once. It's like, leave it alone, all right? So you can use horses, shovels, one bottom plow. It's context specific. What's the most useful tool in your particular context? What are your goals? What are your objectives? Many farms have a skid steer loader. Skid steer loader and the excavator are my least favorite, simply because you look at a plow here. There we go. The plow, the depth of this furrow here is referenced to the equipment. You drop it down 8 inches deep, and it stays 8 inches from the surface of the ground. So if you measure the surface of the ground, you make a little furrow 8 inches deep, it's accurate to itself. It's referenced to itself. Whereas with a skid steer loader or a excavator this way, every time you drop it down, you're readjusting the depth. So they're a little bit slower because you're not having a referenced depth. My favorite tool is a bulldozer with a 6-way blade. It means it can take the blade, tilt it this way, and drop it down, and it's just like a plow. And another reason why I like it is it can make a smooth slope on the way in here. And one of the more critical pieces of equipment for farmers is if they're cutting hay or combining grains, is the cutting bar on whatever your hay equipment is. You can put a wheel right down on the bottom of this trench, and it'll go across here and not cut dirt. You don't want to cut dirt in the middle. It's bad for your equipment. Bulldozer with a 6-way blade. Prickly pear cactus. It works. Really works. Soak that water in. There's another picture when it's laid out over the landscape. What I grabbed from the yeoman's book is like, well, what if we made all of our alleys between our swales perfectly the same distance, the same width all along the way? So what you do is you figure out what your equipment is, and usually multiples of 2 times your equipment. So 2 passes, 4 passes, 6 passes, 8 passes, plus a little slop for Friday afternoon and all that kind of stuff. And then what that allows you to do is be very efficient is you like leave the shed and you go out and you come back. If you only do 1 pass out and 1 pass back, you're working all the time. You don't go down to the end of the field, stop, lift the equipment, turn around, back and forth adjust, drop the equipment and go back. With this space over here that you didn't do any work on, you didn't get any crop, it's the headlands on either side, might as well design it so you just go simple, really efficient design. So, I think this is where I'm going with this. If this was my property, how would I design it? Let's pick a key point. This is not the official yeoman's key point because there are only key points in primary valleys. But if this is my farm, this is key to the whole system. This is going to design the whole entire farm. The whole entire farm fits in with the water management strategy, period. You just do this. Get used to it. So I put in a key point pond. It's in the key point. Well, a key point. And the word pond, you may want to be careful using the word pond. In Wisconsin, if I make a pond, I have to have an engineer, civil engineer, design it. And then we have to build it according to spec using a licensed contractor. Then we have to file the plan with the Department of Natural Resources and with the county recorder. And it has to be maintained as such in perpetuity. It's like, well, screw that. You know, I'm a Spirkovich. I'm a Spirkovich. It's like, no way, I don't want these guys to know what I'm doing out here, so I'm going to dig a hole in the ground. I can dig a hole in the ground and use that fill to fill in a low spot on a road somewhere. It just so happens, what a remarkable coincidence. When it rains, those holes in the ground get full of water. Wow. Not a pond. Well, then, probably the single most significant innovation that I've done with the whole Keyline process is instead of just running a line that's perfectly on contour from the key point, I automatically, right off the bat, if I can, I'll pitch that slope 1%. So it'll be going out 100 feet and dropping 1 foot. And that right there has solved 98% of all of the challenges that I've come up with the whole Keyline system. Once you do that, almost, well, yeah, sure, 98% of the time, when you start doing these parallels up and down, all those parallels, for the most part, will pitch towards the ridges. So go parallel up. But there's a problem here. When we run a line, so I'm a swiler, so I'm putting in swiles. These are terraces, USDA terraces. They're within my 4% because they're 1% slope. As you go down slope, all of a sudden there's this little valley. All the water would come pouring out here, down that primary valley and goes away. So instead of going like this and go ring, 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 which is hard to machine, I'm going to go straight across, smooth curves, whatever it is. But I'm going to have to correct there because I don't want that water to bleed away. So I make what's called a drive-through pond. Take like a pie server and go scoop uphill and then go boom downhill. So you smooth off up here and you fill in down here. And so what ends up happening is your key point pond will fill up, the water will start to float here, then this fills up, then it moves, so it goes, fills up, fills up, fills up, fills up. Why I call them drive-throughs is I don't build these with the intention of holding water unless we want to. If you want to and hold water year-round, design it that way. This is just designed to catch that surge event. You got a 3-inch rain in a day. I guess you guys don't get that very often in California. It'll fill up, and so that day or the next couple days it's too wet to drive through, but then once it all soaks in, it drives in. My goal and purpose of designing farms this way is to catch that rain, soak it in. It's sub-irrigated that way. Well, then out on the ridges, you're going to have to let that water escape somehow. Various different ways. I'll show you how. Keep paralleling up. We put a saddle pond when we can. It's outlets, drive-through ponds, and it's ridge ponds, it's ridge outlets. Well, why on earth would you put a pond up on the saddle? You can't have water up there. So, well, yeah, you can. You collect it from the hills on either side. So these are collecting the water, storing it here, fills up and goes back. this water otherwise would have gone and it's gone, but instead it goes zing, zing, it stays on the farm, sheets off of here, keeps your ridges now become moister, and the valleys become drier. So if you have wet spots on the farm, many people say, oh, drain this for me. It's like, no, let's prevent the water from getting there in the first place and see what it does. Some of the things that we use for design criteria, instead of being an engineer and designing for like the safest, blah, blah, this and that, statistically speaking, maximum rainfall event ever. What was the biggest rain that ever happened on your place, ever? How much water was that on your acreage? And then let's make it so our ponds and our swales will hold that. So in a worst case scenario, we get that. We had 13 inches of rain in an hour once, and we swallowed it all up. It didn't leave. If you have a place with no swales, I don't care how on contour or keylined it is, when you get 13 inches of rain in an hour, it's going to go away. So we kept it on site. So in clay soils, they can be deeper with steeper sides. Sandy soils, it's shallower. The safe design volume measured is influenced by infiltration rate, saturation point, blah, blah, blah. These are what some systems look like. This was Omer's place, or Irvin with the beard. Another place here. This is, what do you think? What do you think this spot is right here? That's like our key point. That's where we started this whole system. The idea is instead of this water flowing away, we spread it out to the ridges. What you can also see there's a little cross piece there and a piece there, a piece there. About every 50 feet or so, 25 feet on smaller systems, I'll just put a little check dam across. So it'll fill up one cell, overflow, fill up the next cell, overflow, fill up the next cell. Slow it down, spread it out, soak it in. That's how they operate in the rain. Just let me ask you a question. Does it appear that this water soaking in has had any effect on the growth of the grass? Just appearances, just appearances. Brandy new system right here, what they kind of look like. This was one we just did in October. Actually, Dana laid it out, and we had a pond that was like all eutrophied and filled in that they wanted to clear out. So we laid out the water management system on the ground, and then we opened up the pond and filled the system, and it was really, really cool to watch it fill up. Now, one of the complaints about swales is you don't want to put swales in. It's going to take land out of production. Well, in this case, if you're going to crop here, you won't be able to cut hay on that. You won't. But if you're going to have animals grazing on it, like this situation here, grass is going to grow there. You can graze on it. It doesn't take land out of production. Or if you design it this way, so your equipment goes here, your 4-row, 6-row corn planter, 4-row, 6-row corn planter, and so on down the line, you can have these swales all over the property, and it doesn't take a single piece of ground out of production. Just what some of them look like. There's more key point ponds there. Now, one of the things that's mentioned in the book, Yeoman's book, is as you do this cultivation pattern going up your ridge, all of a sudden it gets too tight, and you can't turn your equipment here. So you just pull up, and then you do it again. And he has these blank spots that he never addresses in his book. What do you do with those blank spots? That's where I put ridge ponds. This is Darren Doherty's slides. He loves big ridge ponds. He lives in a very arid place. Water is important. You want to store any drop that comes on there, have it in above ground storages. Another one of his projects, once again. Whereas here in the States, I don't want to build dams because I have to have licenses and permits and all that kind of stuff. And my goal is to soak the water in, not necessarily store it later for irrigation. This would be more like what I would do for a ridge pond. It's that same little spot as you're going up. It's like the cuticle thing on your fingernail. It shows these little shapes as you're going up the ridge. You'll have these little odd spots. Another, this one's how do you say level sill in Australian, Colin? Because this would be a level sill. Out on the shoulder, out on the ridge, perfectly level. And then, like the old-fashioned admirals had the strings hanging down off the epaulet on their shoulder. So the water goes from here, through a channel, out to the ridge, and then sheets off the ridge. So now we have moister ridges. You can have an end outlet, because if you take water that's a foot deep and a foot wide, you split it in half, it's now a half foot by a foot wide, and then you stretch it out over a half a mile. How much water do you think is coming out the end? Hardly any at all. So once you get out to the shoulders, the water has been stretched out so thin and had time to soak in that you don't have like this big gully washer going down the middle of it. Another end outlet is the end of the swale right here. This is another one still. This is just the material from the excavation, hasn't grassed in yet. When this fills up, this berm doesn't hold the water because it's just the excavated material. When this fills up, it goes out the end where it used to go anyways. exits right at ground level. Okay, so we got our system in place. This is our basic water system. Key point pond, 1% slope, a ridge outlet, drive-throughs. This sets the pattern for everything. Now we put our trees, fences, roads will all kind of follow this. You can make crossovers if you want to cross. This is one of the things that's in the Keyline book. They say, well, make your roads on your ridges. Well, you know what? If you look at ridges, they're the steepest ground. That's the steepest ground. A lot shallower ground is in the valleys. And so I try to make the crossovers on either side of these key point ponds, and you just make the swale wider, and you just cross up, cross down, go up and over. Don't try to do it in a Jetta. I have a Volkswagen Jetta, and I got them stuck on a couple of times. Plant your trees. They now follow this pattern. You can use shovels. They cut ahead of time using a subsoiler, cut a slot. You can use a hodad. This guy can put in 1,200 trees a day with that tool. It's pretty cool. Kevin, how many trees do you put in a day? Where's Kevin Walls? 6,000, he said? 12,000. There you go. When you're doing a system like this, we're not making like a block planting forest. We're making these linear forests. You're going to have sun on either side. So if like the recommended spacing, this is chestnuts right here. If the recommended spacing is 30 feet, we put these in at 6 feet apart because we have far fewer trees because the alley is so wide apart, and these trees will still get sun on either side. So they get plenty of sun. Tree tubes, if you're in an area that has lots of deer pressure, you'll want tree tubes. Also will protect from cattle, as long as you don't let the cattle eat the tree tubes. This just shows some of the drive-throughs. The key point pond is over here off the screen. The water comes out, goes around the ridge, and wherever these little primary valleys were coming on, we cross over. Most of the times, these are dry. The grass will be growing in it. This actually is up by the key point pond. You notice how we made it smooth so you can cross over here. This is a crossover. They've fenced their trees. They're in heavy deer pressure area, but worse than that, they got sheep and goats, both sheep and goats. So they put individual cages around every single tree and high tensile electric around it. Makes sense. So our pattern is our alley, swale, berm. Now, where do you put the trees? Where do you put the trees? Think about this for a second. There is no single prescription here. Swale berm system, right? And if we got water that fills in right over here, dunk, dunk, see that nice red water? And if you guys want to see a good video on YouTube, Jeff Lawton's Swale plume, that water is now pluming down slope underground. Well, what if we put a tree here? Are those conditions different than if we put a tree here? In California, I've worked with a person. We put the trees right in the bottom of the swale, because if we didn't put them in the bottom of the swale, it's the Mojave Desert. I've worked with a place in Vermont that did this because it's too wet here and it's too wet there, and there's too many rocks and they couldn't put it up here. Up in Manitoba, a place next to Lake Manitoba, is so flat and it's blue clay that we did this. That's the only dry ground on the whole entire farm. So we got trees to establish in a place that's treeless because it's too wet. Well, then on my place, I put them in here. Which one's right? It depends. Depends. What are your conditions? What are your goals? Blah, blah, blah. Prickly pear cactus in the foreground. This is a location that I'm not allowed to tell you where it is, because if I do, they'll shoot me. Once again, spaced according to the width of your equipment, very efficient to farm. When you first set it up, the most critical time is before everything's grassed in. That's the critical time. You get this, if it rains on you, you're going to have blowouts. So get it grassed in as quickly as possible. But what's neat about this is, worst case scenario, let's say the system fails. You design for a 12-inch rain and you get 14. What's the worst case scenario? It's going to go back to doing what it did before anyways. Makes a little blowout, and you're not going to like flood New Orleans. Just make a little hole, go by with a shovel, patch it up. Sound effects are important. Got that? In the yeoman's book, he says, use a chisel plow to scratch lines afterwards. Chisel plow in Australia was different than a chisel plow in the USA. Don't use this tool. This is the most oxidizing, most crumbly thing on the planet. This will pick stuff up and flip it all over the place. It's not what we want to use. What he really meant was use a subsoiler. Basically a hook. Just a hook. We're going to cut slots in the ground. That's my hook. I got it for $50. It was an ornament in somebody's front yard. I never paid the guy for it. Or you go online to King Cutter, K-I-N-G-K-U-T-T-E-R, and get a subsoiler middle buster. Take the middle buster blade off and put the plate on for a subsoiler. It'll cut a slot in the ground. Or you can go online and order a yeoman's plow for starting at $8,500, your choice. Is one better than the other? There's no data out there saying that this works at all anyways. So it's your call. If you want one of these, Super Wombat, Head, Slipper Imp, Vibrapack, Shanky, Pecky, whatever it is, go. Who has a yeoman's plow? Somebody has. We got one over here. It's just sitting in his backyard. I'd love to have you guys rent it. Why not? They make subsoilers small enough to use with a four-wheeler. I'd love to have something like this where you're cutting these little slots and you're putting the seed right on it at the same time, and at the same time you're dropping biologicals in there to really activate things. I'd love to do that in my otherwise idle moments on the farm. What this goes to show you is with these subsoiler slots, whatever tool you're using, we're allowing water and air to soak in deeper. It crumbles the soil, it shatters it a little bit. Then the plant roots really zip down that nice soft soil. What I'll do when I'm growing produce, I'll rip the field first with the subsoiler, then till it up, say for acorn squash, and I try to run the transplanter right down that slot, and you'll see where the ones missed the slot, they're not as big as the ones that made it right in the slot because the roots really run. Then if you go ahead and mow the grass, graze the grass, whatever the deal is, the roots die back, and that's the organic matter, the carbon that you're pumping into the soil. Or you can use a bulldozer with the ripper. Which one's right? We're trying to cut a slot in the ground so the water soaks in and we have faster plant growth. Can you see these slots here full of water? This is on our farm right here. If you're going to be doing this system at minimum between your tree crop and your alley crop, you'll want to at least do that once a year starting when the trees are young, because we're going to root prune these trees so the roots don't come out and steal nutrients and water from our crop. So if you're alley cropping, root prune next to your trees. This is on our farm again. That slot right there, about this wide, 3 feet deep, is 7 gallons per linear foot right in the ground. Did that water go away? It's down in what I have a problem on our farm is that our highest fields, this is highest up on the hill, drought 2 years ago. We weren't able to get into the fields until the middle of June because they were too wet. What? High up on the ridge, longest drought in Wisconsin history, we couldn't get in the fields because they were too wet. Well, once we planted our crop, everybody else's crops died. What about ours? Did just fine. So then these are the rip lines, showing the rip line. So we start with Key Point Pond. If you choose to do swiles, do swiles. When I pre-pitch them, 1%, anywhere from 0.25%, which is either it's 4 inches over 100 feet, no steeper than 1 foot over 100 feet. Then at the end, I'll put a ridge pond outlet, and when crossing over primary valleys, put a drive-through pond, plant my trees, put the fences. Nice, it's very efficiently laid out. The water is spreading out to the ridges. It's accomplishing my objectives. Is that right? Depends. Following about, just doing the impossible, where he said we couldn't, and still getting the same effect. So back to my original point, or one of my original points, it doesn't matter where you key your system. What does matter is that you know what you're trying to accomplish and use the appropriate tools in the appropriate location. And I know I'm going to say it again tomorrow afternoon. It's only going to take 15 years to revegetate the whole entire planet, and we can do it at a profit, okay? This is the way the water used to move. That's the way it moves afterwards. And why are we doing this? We want to live a good life. Let's live a good life and leave this place better for our children and our grandchildren and so on and so on and so on. Sure. If the question, can I stop the water in a V-ditch? Go ahead and use a subsoiler and rip in the bottom of the V-ditch for one, and then accidentally block up the end of the V-ditch where it dumps into your primary valleys, because that's what they do is, it'll try to go into your primary valleys, right? And then into the secondary valleys, you just block it off. Don't let it go in. Yep, you bet. Now water will start to soak in, and then you can have landslides. We can see you on TV. David. Oh, you're trying to ask? You don't get to ask questions. Your staff. All right, so that's a good question, because if I'm doing these rips parallel, they will drop down into that primary valley. Lift the hook, right? Go straight, and as soon as you go down into the primary valley, lift the hook. Or what will happen when doing this sometimes, it'll get really steep, and then you just don't do the hook at all. So, or maybe you want to. Your choice. Marchin. Question is, am I using this to get the land better than before? Now, the word better, do describe, what is a better? Okay, so if one of the things is more biological activity, more vegetation, yes, because we want to have more water soaking in. As the water soaks in, it pulls air behind it. You've created this soft little soil with your rip lines. Roots will grow faster, graze it off or mow it off. The organic matter dies, decomposes. That's back to the beginning of the slide presentation, says that this is how we convert subsoil into topsoil. What was I supposed to mention because you were going to yell at me? We have a workshop next week. We're going to be designing I think it's like a 17-acre site, and we're actually going to do the work while we're all there. So if you guys want to sign up, see this lady in the back? Dana, yay! So what she had said very quietly and meek, because she's a quiet and meek young lady, is the fact that we're going to be doing some more YouTube videos, so specific to water management. Whatever questions you haven't had answers here, go talk to her, and we'll do that in some kind of YouTube video. It says it's 10:01, and Spirit goes up, and he wants his pointer back, and he'll... Thank you.